Welcome, everyone, and thank you for joining this very promising indeed session on software and modeling extension development. I am Ilaria Fusacchia. I'm a postdoc at the University of Roma Tre. I thank you, Ginger Batta from the Center for Global Trade Analysis, who is hosting and recording today's session. And she will also help us ensuring we keep to our allocated time. Before getting to the presentation, I kindly ask all participants, except of course the person currently speaking, to remain muted. As usual, we will have 4 presentations for 20 minutes each. The discussion period will last 10 minutes and will follow immediately each presentation. You can write your comments and questions also during the presentation using the chat, or you can also at the end raise your virtual hand. We will have at the end of each presentation just 2 minutes as a transition period, just to allow the other presenters to upload and share the presentation. And I think it's all from my side. So without further ado, please allow me to introduce our first speaker, Florian from Victoria University, presenting on Runge-Kutta integrators for fast and accurate solution in GEMPACK. Florian, the floor is yours. Thank you.
Okay, can everybody see the slide?
Yes, properly.
Okay, so I will be talking about new class of integrators in GEMPACK. Originally, we only had Euler and Greg's method and midpoint. These are actually the leapfrog midpoint method, just detail on the side. And yeah, their convergence is sometimes insufficient, or in case of Greg and midpoint, they can be somewhat unstable for the way the economic problems are formulated. So we were looking into different integrators, which will do a better job and hopefully will take less steps to give more accurate solutions. And having a background in physics, the first thought was to think about Runge-Kutta integrators, or I should say as a German, Runge-Kutta, but I think it's more common now to use the English pronunciation, so I would stick with Runge-Kutta. Yeah. Okay, so first, I will talk about what we are actually trying to solve and hopefully convince you that the GEMPACK approach with linearization is indeed a perfectly sound way of doing things and will eventually give the right answer if we integrate the problem right. Then I will introduce the way the Runge-Kutta integrators work and talk a bit about some implementation details, so what you will see as a user in GEMPACK, and finally show you what we actually get out of them and end up with conclusions. So let's start. What are we doing in Cge Modeling? We've got our equation system, which we can write out as a vector of equations, E1 to EM, which are functions of the exogenous and the endogenous variables. So I use the notation lowercase letters in bold mean vector quantities. Now, the idea in GEMPACK is that, from economic data, we are able to construct an initial solution. So we don't need to compute a solution to the system. We can construct it from what we know. Next, for the exogenous variables, the variables we kind of determine during a simulation, we want to shock them, and we can express the new state of the exogenous variables in terms of the shock by simply using a linear function of it. So y equals y0 plus t is a scalar, times s. So far, so good. I think there is nothing wrong with that. Now, if we want to solve it, we can formulate the new variables, the solution of the shocked system, as an initial value problem, where we say, okay, xs the final endogenous variables with respect to the shock system is simply the integral from 0 to 1 over the gradient of x with respect to t dt plus the initial state, and the same for the exogenous variables. The only question that remains, of course, for that is how do you compute the gradients dx dt dy dt? The answer for dy dt is pretty straightforward because I beforehand defined an analytical function for it, so we can simply solve it in this way. Oops. But what about the endogenous variables? Well, that is a tiny bit more involved, I'm afraid, but still reasonably straightforward. Seeing we've got our system of equation for which the right-hand side is always 0 if the equations are properly fulfilled, we know as well the gradient of our equations with respect to t has to be 0. Now we can apply the chain rule. So dE dx, dx dt, dE dy, dy dt. And now I just do some redefining to make it look a bit nicer, because the dE dx vector derived by dx forms nothing else than the Jacobian matrix of our equation system with respect to the endogenous variables. Vice versa, for the exogenous variables, we end up with the Jacobian with respect to the exogenous variables. Note that in both cases, the Jacobian is still a function of all the endogenous and exogenous variables, and they can, of course, change over time. So our Jacobian changes with t as well. That's why we can't just compute it once and be happy with it, while we have to do multiple steps and compute it every time. Now we simply rewrite the uppermost equation, solving it for dx dt, and we find that simply the inverse of the Jacobian with respect to the endogenous variables, which in GEMPACK nomenclature is usually called the left-hand side matrix. The inverse of it times the Jacobian with respect to the exogenous variables times the shock, and this Jacobian times the shock is what we refer to as the solution. So we basically solve for this new vector. So matrix times vector remains a vector. So in that sense, yes, we can compute the x dt at any point. And now the only problem that remains is to solve the initial value problem I've given before. And that can be done by integrating it. And well, if you still don't believe GEMPACK can give accurate results, you will have to take it up with the mathematicians developing these integrators for initial value problems and discuss with them whether they can solve it right. But so seeing that, yes, that's what we are attempting to do, and that's why GEMPACK can actually give us accurate solutions. Now, what are the integrators? Here is an illustration how a Runge-Kutta method works. Note, this is for a differential equation, dy dx equals minus 2x times y, which is just, well, the solution to that would be the bell curve. As you can see, just here a cutout of it. If we want to integrate it, we could use Euler's method, which is just a gradient following method. So a single step Euler would just go along the gradient at point 0, 1 and shoot us over here. If we integrate, if we do 2 steps, we move to the half point along the gradient, look at the gradient here, and move down to this point. Note, as the gradients are a function of x and y, we actually have a gradient field, which is different at every point in space. What a Runge-Kutta integrator does is, instead of just looking at one gradient, it tells us, okay, check the gradient at the initial point, then move along that gradient for a certain step size, and have a look at the gradient at the end point. Then use a linear combination out of the 2 gradients we found and move along that gradient for a certain step length. In and so on and so forth, depending on the Runge-Kutta method. We do that many, many times. For the default Runge-Kutta 4 method, we do it 4 times, so we get another gradient point and use a linear combination out of all of these gradients to determine our final direction we move into. That's how Runge-Kutta methods work, and you can see that there are lots and lots of parameters, the step sizes taken, what is the linear combination of gradients we have to use, lots of parameters to tune, and yeah, that's where it gets complicated how to develop these methods, but generally they attempt to minimize the error which is being made. So what is the integration error for these methods? Generally, the integration error for any explicit integrator can be simply given as a series of the form k equals 1 to the order of the equation we want to solve, but could be infinity as well. A constant for each order times the step size to the power of k. That is just the way it is. And the Runge-Kutta methods try to reduce the first non-zero ck as much as possible. Now, for an nth order integrator, like Runge-Kutta 4 is a 4th order integrator, what we end up with is that C1 to C4 is actually 0. So these terms vanish, and the first non-zero error term, so A is the exact solution, AH is the solution you get with a certain step size. The first order error term that is non-zero is CK5 times H to the power of 5. So for a single step of a Runge-Kutta 4, the error or the first order error will decline to the 5th power of the step size. We halve the step size and we end up with 1/32 of the original error. However, unfortunately, one step never does the job, and when we use multi-step simulations, that introduces chaining steps together, that introduces an additional error which reduces our convergence only to order h to the power of n. So Runge-Kutta 4 would only go with the step size to the power of 4 because it's a 4th order integrator. However, some clever people have actually found out that in the schema I described, that you kind of poke your gradient field and figure out where you figure out some trial points. They found out that yes, with little extra work, you can actually construct 2 methods for the price of 1 by using the same trial points, and you can still construct 2 very good methods which have very low error coefficients. These are called embedded Runge-Kutta methods, and one of the most famous one is the Dorman-Prince method, which is a 4th order method, which is a 4th order error estimate with a 5th order method, and it takes 7 trial points or 7 stages. Well, as you can see, it's a bit costly, so we could get 7 Euler steps for the same price, but we get a much better convergence because the convergence goes with h to the power of 5. What we can do, now that we've got a 5th order and a 4th order solution, we can simply say, okay, if we've got sufficient steps, or in general, we should assume that the leading term C5 times h to the power of 5 should be the dominant term in our error series. So we simply neglect the rest. And now we can ask ourselves, can we determine how big our step size can be to still be within a certain accuracy? And that is pretty simple. We say that the tolerance is equal to C5 times the scaling factor times h, blah, 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 goes through the mass. And we find that we can actually compute a scaling factor which allows us to determine how far we can take our steps to stay within a certain accuracy we determine. In GEMPACK, we don't just use the difference because we can have some terms in the millions and some terms of the order 1. So we would the million terms would completely dominate. So what we do, we define an error metric, which is simply if anything is larger than 1, we take the relative error. For things that are smaller than 1, we simply take the absolute error. And we plug that in here. So that is just for information. When you use the method, that's what you are dealing with the tolerance. The tolerance works on the error metric. So the GEMPACK specifics is that we use as well what we find from these error metrics to compute an error estimate for each and every variable and each and every component and write it out to a HAR file, which we call the .ack file. In general, yeah, you could try and push it and kind of, yes, okay, say I compute how far I can go and I take the full step. But if you have to redo a step because the accuracy is not high enough, it becomes very costly. So we introduce an additional chicken factor to our scaling. So we make our steps smaller than what we potentially could do. Means we potentially need 1 or 2 steps more, but on the other hand means as well that generally we will be even lower than the even more accurate than the user-specified tolerance. What we found in the process is in the GEMPACK manual, it's kind of lenient about, you can have minus 100% changes, and you should be fine, or there could be some problems also. Looking at it in detail, the answer is never ever have a percent change variable if the levels can change sign, because higher order integrators go completely berserk due to the singularity in the percent change formulation. So higher order integrators can't integrate over the singularity at the point -100. Euler can, kind of, even though it will never be right. But Euler only cares about the local environment. It does not know it past the singularity. So Euler moves past it and does not complain very much about it, but in general, never ever do it. And for the adaptive step sizes, assertion and range checks usually tell us if something goes wrong, if something breaks about it should never have done. So we implemented it in a way, if you've got range checks and assertions in your model, and in the second stage, so in the second dry point computation, you fail one of these assertions, for example, it will stop there and straight away redo the step with half the step size, because it knows what I will get out in the end will be horrible anyway. So save ourselves the last 5 steps and straight away redo it. So performance and practical implications. We provide 4 different methods. We've got the Runge-Kutta 2 and Runge-Kutta 4 method, which are simply explicit methods. No adaptive step size possible because they are not embedded. But as you can see in the number of stages, that's the number of equivalent Euler steps, if you want. They are very cheap, so we get a 4th order method for Euler steps. But no adaptive step size, which cannot be a good thing. So they are very efficient, but don't allow this automatic adjustment. And we've got the Bogacki-Champine method, which is a 3rd order method with a 2nd order embedded, costs us 4 Euler steps per step, and the Dawn and Prince method, which are kind of, which I used in our example, which is 5th order with a 4th order embedded. Now, how does it look in practice on a real example? So I had one of the COPS COVID simulations, and yes, COVID, big shocks, quite hard to solve. So I used this simulation as my test case, and because it's hard to compare integrators actually, because you find something looks pretty nice with one integrator and another integrator does not look good. So the problem is, it seems like each integrator is good at solving certain parts of the system and not so good solving other parts. So what I plot here is kind of the maximum error metric for all variables in the system for the different integrators. So that's what you are seeing here. That is kind of the worst result, the worst error metric each of the integrators produced for a certain number of LGD compositions. So in a sense, you can call that again the Euler step equivalent in terms of cost. And you can see Euler, well, we go to 40 steps and our error metric is still above 1, which means something is, yeah, error metric, as I said, can either be the relative error or the absolute error, depending on whether it's larger or less than 1. So having an error metric above 1 means basically could be wrong by more than 100%, which sounds horrible. Then we look at a second order method implemented in GEMPACK. Greg's method looks better, struggled a bit, had some assertions and range check warnings up to this point here, and then it converged smoothly. And with 40 steps, we are getting at least to 0.2, so 20% error maximum is better, but kind of for 40 steps, not really great. Then we've got our extrapolation methods, which work, well, quite nice, as you see how they, well, at 40 steps, we basically have a very accurate simulation, but unfortunately, as you see, they are very costly each step. So in terms of LUD composition, so there is that problem. Then we've got the Runge-Kutta form, which, as you can see, just beautifully converges, and at 40 steps is as good as the Greg method.
Hey, Florian, 2 minutes.
Yeah, then we've got the adaptive step size method, and as I said, we just specify the tolerance, and it decides what to do. And with about 28 LUD compositions, it's as good as any of the other integrators at 40 steps. So the nice bit is you don't have to worry about how actually, what steps to choose. It just does a brilliant job. That's why that is kind of the recommended method. Here is this .ag file I talked about, and in the viewer, we've got the feature you can press the middle mouse button on the max column, and it will sort it beautifully. And that's how a badly converged simulation looks like. That you see all the variables have a sizable maximum error metric. So that's the maximum component. We can have false positives, of course, if you've got a equation like this. Ordinary changes, you take the difference between two of similar size. What you end up with is a low error metric for A and B, but seeing that delta, pardon me, that delta AB is small, we get a large error metric here. So in this case, we would see a single component in our system just having a bad error metric. So that would be a false positive, because you might actually not care about that too much, or the error is negligible nevertheless, just from the way we write the mask. And finally, we might end up with bad model code, which happened in COPS, and actually the Runge-Kutta methods found it out. So as you see here, area of a square, linearized form. Here is the bad one, that we use the area instead of the length in the linearization, which turns our level solution to an exponential instead of a square. And we can see that for the first case, we get quite a bad error metric, whereas in the other case, it is perfect. And then if that happens in your code, what you will see, that there is a bad equation. You will see one variable, one equation with a large error or a block of connected variables, and the rest of the system will be fine, because in Cge models, generally the errors then smooth out via the share-weighted sums also, so they kind of decay. Okay, quick to the conclusions. I had to rush a bit, I'm sorry. As I said, they are well suited, they are more stable than Greg and midpoint. We've got now a very well-defined accuracy, so we had the adaptive step size in a sense for the 2, 4, 6 methods as well, but that was a bit ad hoc in the way the error was defined and the step size adjustment, so that is now great. You get higher accuracy, time to solution. If time to solution matters, use RK4. Otherwise, if you just want to run your sim and get an accurate result and don't care about anything, dormant prints is just the one you want to use, because it specifies one parameter and be happy with it. And yes, so the adaptive step size works as well with recursive dynamic models, which people were worried about. But within COPS, that has been used extensively now, and yeah, found that everything works super smooth. Yes, I hope I made it roughly in time.
Yeah, thank you, Florian, for the very interesting presentation. Now let's take some comments or questions from audience. I don't see questions on the chat. Tatjana, please.
Okay, I first have a question that might sound very either simple or stupid to you, but what is your control group when you look at the errors? Like, how do you find out how far off your method is from a real solution?
That is the difference between, so we basically, with the same trial points, we can construct a 5th order method and a 4th order, well, 5th order solution and a 4th order solution, and we know how the error evolves. So it's simply assumed, because the higher order methods get smaller and smaller with the step size here. So that's common in math, that you then neglect the higher order terms and simply say that the maximum error we should make should be given by our 5th order error, which we then can compute as the difference between the solution from the 5th order and the 4th order method. So it's simply the assumption that the higher order terms are all smaller than the leading order term.
Paul Gretton also.
Yes, thank you. Thank you. Florian, I've got two questions. One is, in your presentation, you mentioned the possibility or the difficulty that you'd encounter if a variable or a coefficient changes signs, now particularly a coefficient changes signs. Now, in the GTAP database, this could be a snag, because, for example, national savings in the database for a number of countries is negative, but it's not naturally negative in a long-term sense, and it should be modeled as coming positive over time. Have you thought about this, and have you any suggestions about how that problem might be dealt with?
Use ordinary changes. That's the only way about it. By using percent changes, you always have a singularity in the gradient at the point -100%, and none of the integrators can get that point right. So in the limit of infinite steps, it still doesn't work. In the limit of infinite steps, even Euler will completely fail, because it will hit the 0 point, and from 0% changes can't move anymore. Mm-hmm. So you need to change it. It needs to be changed to ordinary changes. My view.
Yeah. Thank you. Yeah.
Wolfgang, please go ahead.
Yeah, Florian, thanks for this quite interesting presentation. I'm coming from the games world, so I'm used basically to define a feasibility tolerance on my equation system, basically, which must hold for any equation. So is this something which you can do with what you presented? So basically, let the method run until you're sure that your maximal error is below a certain threshold.
Well, you don't let it run. Well, the point is, it does not get better the longer it runs. You need to beforehand define how many steps you want in an initial value problem, or, as I said, with the adaptive step size, you can set this tolerance criterion, which is an estimate that, well, if we would know the exact errors, we could just add them and get the accurate solution. It is just an estimate, but what I did, for example, here in the comparison was that I compared it to a 400-step Runge-Kutta 4 solution as my reference solution. And yeah, for everything I did with these accuracy files, when I tested that it actually makes sense, I compared it to such a high accurate solution and found that in 99% of the cases, the given error metrics were actually overestimating the real error. So in that sense, I would say that it's very trustworthy when you see that here you got all zeros or very small numbers, then you are good. I mean, there is, well, we've got the face value in GEMPACK, which kind of gives you a smiley face if we think the solution is good. And I decided for these methods, you only get a smiley face if the maximum error metric over all variables is smaller than 0.02. So basically 2% error maximum in the whole thing. But you can get more accurate without problems with these methods. Does that answer the question, I hope?
Glenn Whitwer also has a question.
Firstly, I'm an in-house user at COPS of Florian's software update. And the main thing I find is in complex dynamic simulations, when you're in a hurry to get the right result, the do pre-54 is excellent because the simulation will fall over early if there's a problem. Now, normally I'm used to having to do forensic analysis on whether the updated database is balanced and whether the solution is interpretable. But with the do pre-54, it falls over first. And not only is it quicker to diagnose, it's quicker to run. And so there's a considerable advancement in terms of dynamic modeling on what we've had in the past.
I think Dominic has
his
hand raised still.
Dominic, please.
Did someone call me? Because I'm having a hard time hearing.
Yes, go ahead.
Hand raised. Yeah.
Okay, good. Thanks, Florian. I'm a little bit like Wolfgang. Some of this is a bit opaque to me. But one question I had is that I wonder if this impacts the welfare decomposition that the GTAP model uses.
You would need to explain the problem with the welfare decomposition. I'm not familiar. Well, not
I don't know, Glenn. Do you know? Would you know how to explain that to Florian?
Look, I'm very pragmatic, Dominic. I'm not as analytical as you. What you need to do is send Florian an example to work through. I think that's the simplest way of answering the question. It's much easier to work with the software and explore rather than try and think ahead. That's the way I do it anyway.
All right, Florian, I'll get in touch with you bilaterally.
Yeah. Mark, please, and then Erwin.
Me?
Yeah.
I was going to answer Dominic's question. The welfare decomposition will work as before. And I can also answer Wolfgang's question, I think. So in GEMPACK, typically, we never write down the levels equation. We give the initial solution and formulae for computing derivatives. Yeah, so we can't just easily compute the errors in the equations.
Okay.
I think it's time to move on to Erwin's presentation, Ilaria.
Yes. So thank you again, Florian. Our next presenter is Erwin from Purdue University. We'll talk about the modular source code for GTAP version 7 models. Please, Erwin.
Okay, thank you, Ilaria. Can you hear me?
Yes.
Yeah, so just going back since Mark answered Dominique's question. So normally what we do is to make the welfare decomposition more accurate is we add more accuracy into the solution settings. So for example, we add more subintervals or other things that we can add in the CMF file. Anyways, going into my presentation. So I'm presenting something of a work in progress, modular source code versions, modular source code for GTAP version 7 models. Okay, so just an outline of my presentation. I'll give you a quick preview of GTAP model history. The work that has been done on the version 7 model, just to convince everyone to move from the classic GTAP 6.2 model to the version 7 model. And then I'll identify the current GTAP suite of models that we have for both classic and the version 7 model. And then I'll give you a preview of what I refer to as modular source code. And then I'll end with next steps. So just on the model history, so the first GTAP model documentation came out in 1997 through Tom Hurtle's book, the Cambridge Press GTAP model book, with an explanation of the model and some and a number of applications that are tied to the standard GTAP model at that time. And then about 5 years ago, we started work on the GTAP version 7 model, which basically updated the GTAP 6.2 model code that had a number of modifications but were not documented. So for example, there was the new regional household demand extension, there was the international margins, and then all the other things that went in 6.2 but were not documented as a single piece. Add to that the welfare decomposition that Dominique mentioned earlier. So in the GTAP v7 model code, we rewrote the model code in such a way that it follows the documentation, so users can read the documentation and then the tab file side by side, so that it would be easier for everyone to get into the model, we hope. And what we did is we also changed the valuations from the agent market world to basic price, producer price, purchasers prices. So if you're still using the classic 6.2 model, I think it would be good for you to move to the v7 model, partly because the code has been reorganized and are clearer now compared to the older one, plus all the other new model extensions that were built post V7 will not be supported by the classic version, but will be supported by the version 7 model. So just to identify some of the things that were added into the GTAP V7 model code. So we introduced the make matrix. So it's now possible to have a non-diagonal make, that is, an industry can produce more than 2 commodities, 1 or more commodities. At the same time, a commodity can be produced by more industries. So in the first one, think of it as, let's say, there's one agriculture industry producing many agricultural commodities. On the other example is there are many industries producing just one homogeneous commodity. So a perfect example for that is electricity, right? So you have a lot of different energy or electricity producers based on their technology or input type, but all of them are producing the same homogeneous electricity. In the GTAP V7 model, we also made output taxes activity and commodity and region specific. So that converted that previous 2 dimensions into a 3 dimensional variable or value flow. So the reason for that is, let's say if an industry is producing more than 1 commodity, it would be possible to do a simulation wherein you subsidize 1 commodity that that particular industry is producing, and then tax the other commodity that that particular industry is producing. So you can think of it, let's say, going back again to an electricity example. Let's say you try to subsidize green energy and then tax the fossil fuel electricity commodity that electricity industry is producing. We also added a few things. So most variables that didn't have a regional dimension before now have a regional dimension, particularly the key elasticities in the model, although the elasticities are still generic across regions. So for example, for the Armington elasticities, it is possible now to make them regional specific, particularly if the user has data. We also classified the factors into different categories. So previously there were only mobile and sluggish factors. In V7 we had we have mobile, sluggish, and sector specific factor, with the sector specific factor being the natural resource factor. We've also modified, at least for the standard model, we've modified the production nesting to include aggregate intermediate bundle, which I will show you a diagram or a chart, a picture in a while. Same with output taxes. We also made income taxes activity and factor specific. So it's possible now to change, for example, the tax on a particular factor, the tax or subsidy on a particular factor across industries, although the values are still generic because the data that we are using does not classify across industry, but it is possible within the simulation to do some tax simulations. We also added CES functions for government and margins instead of the previous Cobb-Douglas implementation, although we're still using a Cobb-Douglas parameter, so that this CES function goes back to Cobb-Douglas, but it's possible to change the elasticity to make it into a CES. So when we did the model code, at the back of our mind, we wanted to have a clearer model so that it's easier to understand, especially the code. So what we did, for example, is to move from the agent market world valuation towards supplier basic and purchaser's price. This made it easier, especially in the short course, because we are used to having tax rates as being positive and all subsidy rates being negative, right? In the previous version of the model, so for example, for export taxes and output taxes and income taxes, a subsidy is positive and a tax is negative, but only for those particular taxes. But in the V7 model, those not inconsistencies, but those taxes are now following intuition. That is, all tax rates are positive and then subsidy rates are negative. We also separated commodities and endowments, for example. The output of industries are now just QO, whereas the supply of endowments are now just QE. So we disentangled all endowments from QO. And investment expenditures are now treated like public expenditure. So we eliminated the CGDS activity and treated investment as a final expenditure, consistent with practically all CGE models. We also, as I've said earlier, we also harmonized the code and model documentation, including the conventions for coefficients, variable naming, and all sorts of things. And then we made it easier by making sure that each equation follows, each equation name is named based on the variable that is explained in that equation. This makes it easier, particularly for model development, because when you add equations, and you don't really need to count the number of additional variables and equations anymore. If you follow this naming convention with the equations, you can use tabmate's automatic closure utility, and that will give you the structural closure of the model, or what we call the standard closure of the GTAP model. Okay, so this is just an example of what we did for V7. And then here are some of the value, quantity, and price linkages, which you can read on in the paper. Okay, so Ginger, how many minutes do I still have?
You got like 5. You're good.
Okay, all right. So I'm so just on the GTAP modeling philosophy. So whenever we think about doing a source code version of the model, or this modular idea, for example, there are a few things that we need to think about. The first one is pedagogy. Because of GTAP-U, we always need to start with the standard model for teaching purposes. And in the standard model, we have generic modularized components that can be readily modified. So as stated in the GTAP V7 model paper, the idea behind the standard model and having different files for model extensions is that there's this idea that no model can rule them all. So what happens is there's always this standard model, And then from this standard model, you can build your sophisticated extensions or other things that you want to tackle. So for example, a particular policy issue or a biophysical dimension or a particular economic issue. The other thing that we have to bear in mind is that GTAP users have been used to using any GTAP model extension or suite of models fairly easily. So whenever they shift from, let's say, GTAP, standard GTAP to GTAP-E, we try to minimize or lower the barriers to entry so that it would be more or less painless for someone to go from one model file to another whenever they're using different models. And at the same time, we also need to ensure consistency when porting GTAP model extensions. Okay, so here's the meat of my presentation. It took me a while, but I'm getting there. So when we started the V7 coding work, we didn't realize how much down the line implications there were there would be for GTAP suite of models. So here's a count. Of course, there are other things or other models that I may have missed. So basically, these are the static models. The first three bullets are models that have been transitioned to V7. I included GTAP bio here, although it's because it's an easy fix to just put it in the make matrix. And then the last three, so GMIG is the model that I'm currently porting, and then after that GTAP POV, and then GTAP HET will probably it depends on further conversations with Zeynep. And then there are GTAP dynamic models, GTAP RD and GDyn. And then here's an upcoming model that we are working on, which we call GTAP Integrated Assessment Model. So in total, if you count all of them, there are at least 26 models, plus 26 STI files and 26 CMF files that we have to maintain. Okay, if we're producing one model, one static model separately from another. So that means you have 12 static models, and then you have 12 another plus 12 if you have GTAP RD, because GTAP RD is modular, so that you can just add them at the bottom of each code. And there are a few changes that needs to be done in some cases, in some modules. And then, of course, this will be 24 if you want, if you're a GTAP or a GDyn user, and then you want to have all of these features in GDyn. And there's this another one, which is GTAP IAM, which is a recursive dynamic model with almost all the features of these different models on top. Okay, so when I refer to source code, there are two source codes that I refer to. The first one is preparing basically a boilerplate document, a large boilerplate document that starts out with a with a standard GTAP model, but includes switches in certain areas, so that when you query, so that you can identify which one is a part of GTAP, the standard model, and which one is a part of another model extension. So for testing, I've been using Mark.
2 minutes, Erwin.
Okay, almost there. So for testing, I've been using Mark Horge's pre-pro utility. So basically, this one will allow you to generate tab file, STI, and CMF files for a GTAP model extension that you want. So here's a simple example. So let's say you're using GTAP v7, the standard model, and we have here pfact world. So that pfact world is defined in the v7 as this equation. But if you're using the Fisher version of v7, that is with a Fisher index, this pfact world in Fisher becomes pfact world old, so we maintain it. And then in GTAP Fisher, this pfact world is now the geometric mean of the Lespierre and the Pasch index for that particular factor. So this is something that so what happens is you have this large boilerplate document, and then in this you have a DOS box, for example, and then you type in that DOS box the particular model that you want to generate, and then it will create the tab file, the STI or the CMF file for that particular model that you want. So I'm at this point, I'm thinking we can actually drop the STI file, which contains the condensation file, and then just put the condensation as part of the main model tab file. But that's something that still needs to be thought about because it might have an implication for on GTAP. Okay, so finally, there's this other idea that's distinct and is particularly suited for having just one big model, wherein you have all the extensions that can be turned on or off. So this is still a work in progress. Currently, I'm working on the GTAP IAM, which includes all the features, almost all of the features of the other models. And then once that is operational, what I'll do is I'll add shifters or binary switches so that we can turn on and off certain modules, for example. So this is still a work in progress. So the next step, just to end this presentation, is continue work on the large boilerplate document as I finish all as I finish the remaining models that needs to be ported into v7. So that that means adding GMIG and then GTAP POV to that large boilerplate document. So the idea here is that any GTAP user can use that large boilerplate document, have a DOS box, for example, and then type in there the model that they want to be created, and then after that, the tab file and the CMF file will be generated based on that particular model. This way, it reduces the burden on users, so that there is consistency across all GTAP model versions. And also it makes it easier for users to find GTAP model versions on the GTAP website. Even me, for example, I find it difficult to find certain GTAP model versions on our website. So with this one-stop shop, for example, that addresses that issue. And then we will eventually construct one modular model wherein that has switches or shifters that can be turned on or off. But this is still well into probably next year for next GTAP conference. Okay, that's it.
So there is a question by Wolfgang on the chat with regard to income taxes by factor and industry. Dominic already answered, but I don't know if you want to add something. So the question is, already aggregation over regions should lead to industry differences, right?
Yes, that's right. In fact, we noticed there was a mistake in the initial v7 model code when we started playing around with these activity taxes, income taxes. That has since been fixed. It was generating some unintended welfare consequences, but that has been fixed. one thing I wanted to add is that Florian just mentioned earlier that they are now working on a version of GEMPACK that allows you to have certain include file, for example, right, Florian?
Well, that's far in the future. I mean, there is some include file facility, but yeah, that's for the moment, yeah. Better keep working on something that is less vaporware than what I mentioned.
There is Roberto that want to ask something.
Yes, I have a very simple question. This is all very attractive and ambitious, but it always requires the use of GEMPACK. In GTAP, there is also the option for those who don't have a full license or for simplicity to use Rangita. So my question is, what is the level of integration between GTAP v7 and Rangita, if any?
So the v7 is part of Rangita. So there are folders in Rangita that are so let me backtrack. So the v7 tab file is included in Rangita distribution, and then there are version folders within Rangita that replicate what the previous 6.2 version is doing. So for example, for the GTAP short course, there's this folder called ACORS, ACORS 3x3, which is being used for the classic GTAP model. There's a corresponding folder of that in Run GTAP, which we call NCORS, NCORS 3x3, where N refers to the new model. So we've replicated almost all of the version folders in GTAP for both, so that we have both the classic 6.2 and the version 7 model. Yeah.
Okay, thank you.
Okay, I'll collect the last two questions from Paul by Paul and Florian, and then you can answer to both, because we have just 4 minutes.
I'll be very quick. There's two questions. One very simple question on the GDyn. I'll leave you to answer when you're ready, but when will that be available in a sort of, at least in a test way? So that's the first question. But a more important question is the databases you outlined with the additional detail is going to produce a lot more small value flows, which in a simulation can easily go negative, even with the method that Florian's just outlined. Have you been giving any, but this is particularly in the dynamic setting, have you, and more detailed sectoral and country classifications, have you been giving any thought to handling error handling for the occurrence of small negatives that crop up particularly in dynamic simulations?
Okay. Let me first answer your question in relation to my presentation. So what I've been doing for this module, well, it's not really modularization, but so all the models that have been ported to v7, the main challenge I had was whenever we make a change to the standard model, for example, I need to do that for each of the 12 static models. Yeah. But with a boilerplate document that combines all of them, if I make a change to the standard model that is also being used in all the other models, then I only need to make a change to one file. So that saves me time in doing all the changes, and I don't have to do a lot of to use diff softwares just to identify where the issues are. So for the data, it's a good point. So I'm glad that Florian mentioned it. So for example, your question earlier on saving investment, in the GTAP RD model, there's this variable, I think we call it del_f_save, which is an ordinary change variable that calculates foreign saving. So with that, if it's so that's one less possibility of a variable crashing, because saving could go from positive to negative, right? So yeah, we can probably discuss a bit more. Bilaterally.
Most interested. Yeah.
Last, very brief question, please, Florian.
Yeah. Well, I'm just interested whether the modules are mutually exclusive, or whether you plan that certain models can kind of be activated together. I mean, if that's the case and you allow it, you end up quickly with a combinatorial problem: which modules work together and which not. I don't know. Is that something you think about?
I didn't think about it, but that's a very good point, actually. Yeah, I didn't think about it. So what I was thinking was just, let's say you have GTAP E and GTAP AEZ, or which is the land use. Let's say if you don't want the land use part, you can just turn it off, and then it goes back to the standard one land specification instead of 18 land specification. That's the modularization and turning on and off that I refer to here. But yeah, I didn't think about that combination issue.
Wolfgang, we have almost finished the time.
Yep. Perhaps one comment. I mean, the real challenge starts if they are really not, if they are not only, let's just say, combinatorial, but they are overlapping. Yeah. So let's say you want something like the HET formulation for some markets, and for the rest the standard Amington, and then for a few even the HS kicking in. I think that's where the real challenge started. And I should also say, I mean, you go with testing and quality management in a completely different domain if you have basically this combinatorial possibilities or the overlap. I would happily discuss this with the GTAP team, because I'm running the CGE BoxX in exactly this problems, how you probably test such a modular system with this combinatorial problems.
Yeah, thank you, Wolfgang. Let's keep on staying in touch. Yeah.
It is a pleasure now to introduce you Tatjana from the University of Göttingen Kühnen Institute. She will present us modeling the interaction of complex tariff regimes. Please, Tatjana, the floor is yours.
Thank you very much. I hope you can all see my slides, and all can see them without seeing the reference view.
Yeah,
so it's what?
Yes, perfect.
Okay. Perfect. Good. Thank you. I'd like to talk about modeling the interaction of complex tariff regimes today. And what I mean by that is I'd like to specifically model the interaction between tariff rate quotas, ad valorem tariffs, and specific tariffs. You probably all know that, but just as a short recap, tariff rate quotas are quotas that grant a certain access up to a certain amount to another country where the tariff is very low within, and anything that is imported beyond that is then subject to a much higher tariff, often the MFN tariff. Ad valorem tariffs are tariffs that are expressed as a percentage of the value. And for instance, if you want to import something for 100 years of worth with the ad valorem tariffs, it becomes 120 years. And specific tariffs are tariffs that are connected in some way to a property of a commodity, for instance, 20 euros per ton or per percentage milk fat or something like that. And my paper argues that ad valorem tariffs and specific tariffs can both influence the license distribution within the tariff rate quotas, assuming that there is some kind of secondary market for quota licenses. We have some empirical literature that shows that there is at least concerns that secondary market for quota licenses appears. The European Union has specifically addressed that in the CETA agreement, for instance, that they are concerned that there is a secondary market already taking place, and also other papers in their outcomes for the quotas and their distribution kind of point towards that. So yeah, I'd like to dig into that a bit. And for this, would like to first explain the effect that ad valorem tariffs and specific tariffs each have on a secondary market for quota licenses. Then talk a bit how I'd like to include that in modeling with MCP equations, explaining how I'd like to include this into the CGE box, and give some expected results and a little bit of a conclusion on why I think it's worthwhile to go into this direction. If you'd imagine a market where you'd have a heterogeneous set of commodities, all of them see different demand curves, all of them have different supply curves, so are offered at different prices. We might have cheap and expensive commodities here from commodity 1 to commodity 4. And all of them might see the same ad valorem tariff, but for all of them, that means something else. Like for the cheapest commodity of €2, that's just a €2 margin. And for the most expensive of €8, that's a 16% margin. If we'd now introduce some kind of quota, and we'd say we initially distribute the quota equally among all of them, we could see that they all gain some kind of quota rent by having this kind of quota. But the quota rent is very different to all of them. Again, like we have the cheap commodities who kind of save on €2 per license, while more expensive ones save on €6 per license. And we can see that commodity 4 here, for instance, also just benefits with a premium of €6 because they are only importing inside the quota by now. They are not exporting outside the quota anymore with the license that they've been given. In such a situation, it's clear that the shadow value of a license is very different to all of them. And if they are free to transfer the licenses now and actually maybe also take a bit of a price for that, then a license would wander from the trader of commodity 1 to the trader of commodity 4. This would then, of course, affect the quota rent that that person or that trader is seeing. And we could wander around further and further until we have some kind of equilibrium where the shadow value of a license is equal to the equilibrium price of a quota license, as far as this secondary market is actually a functioning market. If we now imagine okay, well, we first have to say this is the ad valorem situation. So in an ad valorem situation, apparently, the license tend to wander a bit more towards commodities that are more expensive. And that's obvious because if we have ad valorem tariffs, more expensive commodities see a much higher opportunity cost of not getting access to this quota. So they are willing to pay far more for this. While this equilibrium price that we have in the end here with €4, that's a price that the cheapest commodity, who just has a €2 margin, they would never afford that. I mean, obviously, it's just cheaper for them to export outside the quota than to pay for a license at this price. So there's a distortion of the market towards more expensive commodities. If we now have a market instead where we say we have specific tariffs and all of them gain the same kind of license, again, same picture, but this time, no matter whether you trade an inexpensive or an expensive commodity, you always see this margin of €4 on top of your commodity price. There is no such difference between expensive and cheap commodities. All of them have the same opportunity cost, and none of them really have an incentive to trade their licenses because it has the same shadow value to all of them. Well, does that mean that there's never an incentive to trade licenses when you see specific tariffs? Not quite. We could have a market like this one, where with this one license that the different traders are given, some of them now import only inside the quota and only achieve a quota premium that is below the out-of-quota tariff rate, and some see a premium that is up to the full quota tariff rate, and then like the shadow value again could differ for them. So in such a situation, for instance, it's clear that the license holder of commodity number 3 would maybe give away his license to someone like the trader of commodity 2, who would thereby be able to benefit of this quota rent and be able to pay for that license. And then we'd again reach some kind of equilibrium situation where all of this is evened out. But what is very different compared to the ad valorem situation is that at some point we will reach an equilibrium where this is just good enough. And at this first equilibrium, we will stop. And we can imagine that this is not the only equilibrium that we see in the market, because the opportunity cost is so similar to all of them. We might see that, I mean, already in this picture, we can imagine that the license holder of good number 4 would instead have half a license less, give that to the license holder of commodity 2, and nothing would change about the situation. That would be just as much of an equilibrium. And this means what I do expect when we have strong specific tariffs in our tariff regime, then we will probably see a higher dependency on our starting values in the model. While when we have ad valorem tariffs, there is a strong incentive to trade and trade and trade until the equilibrium is reached, which might be the only equilibrium that we see in the market. Good. So if we summarize this very shortly now, what the effect is, it's that ad valorem tariffs favor expensive commodities in some form, while specific tariffs outside the quota also lead to a market distribution of some extent, but there is no strong advantage for expensive commodities. How do we implement this now into programming? Well, for this, it's very handy to use mixed complementarity problems. They are a kind of setup in which we connect a variable with an equation, and the state of the equation, whether it's binding with a greater sign, an equal sign, or a smaller than sign, is directly related to the state of the variable, whether that variable is at its upper bound, between its upper and its lower bound, or at its lower bound. So if we first say, very simple idea now, let's just say there is just one quota, just one commodity, and a tariff just consists of an ad valorem tariff. How would we model that? Then we would just end up with one equation and one ad valorem tariff that depends on that. And we could say, as long as our quota is bigger than the quantity that we do export, a tariff is apparently at the in-quota tariff rate. If we export just as much as we can under the quota, then the quota is binding to us. A certain premium is added on top of the price, and the effective tariff that we see in the country, like domestically, is somewhere between the in-quota tariff rate and the out-of-quota tariff rate. And finally, if we have exports outside the quota, so if the quota is smaller than the total quantity that we're trading, then the tariff is at the outside quota tariff rate. This can be expressed, all of these different states, in just this connection of having one equation and one variable, and then the model can decide themselves in which kind of state of these three that we see underneath we're ending up actually in the equilibrium. But this is not all I want to do. I don't want to only have one commodity per quota, and I don't only want to have an ad valorem tariff, but also want to have specific tariffs. I want to have an endogenous distribution of the quota licenses and all of this, so I need a few more equations. That's of course a bit tedious, so I'll try to simplify the concept a bit. The first kind of equation asks if there are exports outside the quota, and if they are, then the tariff needs to be as high as the outside quota tariff rate which is composed of the specific and the ad valorem component. The next kind of equation that I have in here basically just says that if a trader trades only outside the quota, that's probably because he cannot afford a license. So the premium that he reaches is lower than the license price in equilibrium. And if his premium is at or higher than this license price, then he can probably also trade a proportion of his quantity with licenses. And the last variable that I'm putting in here is very straightforward because it just says that all the trade that does not take place within a quota is a trade that takes place outside the quota. And that's of course always the case. This is not something that depends on the state of the variable. So I just don't give any bounds to the variable so that this equation always has to be binding with an equal sign. I want to put these equations into the CGE box, which is a flexible, extendable modular code base for the GTAP model in GAMS. It's very handy that it's written in GAMS because that means I can use MCP equations in there. It also already has a tariff line module in place, which is also very handy because I would, of course, like to model my tariff rate quotas at a very high level of disaggregation. And it actually already has some kind of module for tariff rate quotas, but this tariff rate quota model is closer to what I explained at first when I talked about MCP equations. It basically says one commodity can be inside and outside the quota. And that's not what we see in the real world. So it uses a little trick. It assigns licenses to all of the countries and commodities that have access to the quota. And then it keeps these licenses binding. And that means, in fact, the quota is split up to very individual quotas. And each individual commodity can then see if it's at or below or outside its personal little quota. And there is no trading of licenses whatsoever. And there's also no inclusion of specific tariffs, of course. So I'd like to build up on that, but extend it a bit so that other effects can be taken into account as well. What's the kind of results I would expect? I have to say to expect because right now it's not running quite smoothly. I'm not quite there yet. So I have to say what I would expect. And I would say, like, if we have some kind of market in which, for instance, sweet corn on the very left here is traded and its tariff profile is very strongly influenced by ad valorem tariffs. And if we would have a commodity like cheese being traded and the tariffs in there are a mixed tariff that are strongly dominated by specific tariffs, then those two should act differently as soon as we have a quota both for sweet corn and for cheese. In the sweet corn case, we might see something like this. So beforehand, we had these blue dots and the unit value and the traded quantity were connected in some negative form because consumers just viewed sweet corn, maybe not as entirely homogeneous, but as more or less. And if you trade that as a very expensive commodity, then they are just less interested in it and buy a little less of it. And you see this just normal responsive demand that lower prices also lead to higher traded quantities. But as soon as you implement a quota, you end up with these green dots, which actually are tilted in a different way, because now the most expensive commodities are those that can afford to gain a quota license and are thereby imported at a lower price because they only add up a little quota premium, but they stay way below the outside quota tariff rate. Well, if you're trading a cheap commodity, you can't afford the outside quota, you can't afford the price of a license, and then you have to pay the full price and are actually not getting any cheaper by this liberalization. So we can see kind of three effects from before to after. One is that, of course, the quota did liberalize the market and way more is imported afterwards than beforewards. But the next thing is there is a different tilt in this trend line between our points. leading to a higher inclusion of more expensive commodities. And in total, we can see that our average price level is probably increasing by the inclusion of a quota. For something like cheese, where we said, okay, we have a mixed tariff and they are strongly dominated by a specific tariffs, these effects should not be that strong. We also see that the quota liberalizes the market and we import more, but this shift of tilt is just very small, and there's probably still a negative dependency between quantity and unit value. And also our average prices don't really increase that much. So what is it that our model can provide? Well, we can see by this kind of extension the specific tariffs and ad valorem tariffs and how they affect the distribution of quota licenses. And at the same time, we can also let several quotas interact. I did not dig into that part really, but I also just included it in my equations because I thought it was cool if the model could do that. And the question that this answers is kind of, we might have an on-paper liberalization for some kinds of commodities. Let's imagine we have a quota for fish. And in this quota for fish, we allow for all kinds of different commodities. We allow for salmon to be imported in there, which is a very expensive commodity. And we allow for carp to be imported in there. And now both the domestic carp and the domestic salmon producers wonder, well, will this affect our kinds of markets at all on the domestic level? Will there be a large influx of imports now? And that strongly depends now on the tariff profile that is active outside the quota. And it could be that we have an ad valorem tariff, and we can see that mainly the expensive salmon will flow into the market, while carp will stay just as expensive as it was before, and the carp producers will not be affected at all. Or we could have specific tariffs, which will lead to roughly equal access for all of these commodities. So carp and salmon producers are equally affected. We can answer a few questions on whether we see an effect in high-end products or low-end products if both of them are just included with different tariff lines in the same quota. And this is important for all kinds of trade agreements between developed and developing countries. The developing countries might say, okay, well, we're not really competing on the level of low quality products. If there is an influx of cheap products, well, yeah, that might be unhandy, but that's not really the kind of consumer that we're trying to reach. We're working with high-end products anyways, so it's okay if there is an inflow of low quality products that are cheap. But it is important to us if expensive commodities come in here, because the quota gives a strong incentive to them to actually use up this entire quota just for the most expensive products. That might influence the local market much more. So the question that I'd like to answer is kind of this kind of question: what's the de facto benefit from the access for different kinds of commodities? And yeah, I hope that I could all take you along with the rough logic of what I want to do, and like to thank you for your attention. And I'm looking forward to all the discussion and critique and questions.
Thanks, Tatjana. You have been very, very precise in time, and thanks also for the very interesting presentation. I don't see comments on the chat.
I can make a comment if you wish on the quotas, because I'm from Australia, so it's night time here, hence the light. But we had a system of quotas in Australia in the 1970s and 1980s. It's since been unwound. But what happened and it applied particularly to textile goods and motor vehicles. So it's probably and some foodstuffs as well. So it's probably similar to the range of commodities you're looking at. And in that regime, what actually happened was exactly what you described. The expensive items came in under the quotas, and the cheaper and the less expensive items came in under the tariffs. But probably more importantly, from a policy point of view, it was the way the system was unwound. So we virtually have no quotas now. The system was unwound by setting a tariff fairly high, which happened to be 40%. But with the quota, it was progressively expanded. So it progressively became worth less and less until it hit 40%. And then the policy there was to reduce the tariffs. So if you're sort of thinking of your trade agreements as progressively liberalizing markets, that provides a kind of model that you might find attractive, that you set a quota, whatever the quota is, and probably to make it attractive from a policy point of view, you'd probably set it higher than it needs to be in the first instance, but have provision to gradually reduce that quota towards the tariff. And have exactly what would happen, or what happened here was exactly as you described in your model, or you described in your intended model. Is that, I just make that comment. I don't know if it's worth responding.
That's extremely cool to hear. I actually saw several pieces of empirical literature that that showed a bit that there was a price effect with the implementation of quotas, but what I mostly saw is Taiwan and Korean and Japanese commodities, automobiles, and also footwear to have this kind of increase. I didn't see literature yet on the Australian case, and it's really interesting that you...
It's probably a bit dated now because it all happened. If you wish to have a key reference, is the 1984-85 Textiles, Clothing and Footwear Inquiry. That's when it really all started. But it happened over the second half of the 80s and the early 90s, this process. And it just finished only a couple of years ago when they reduced the tariff on motor vehicles to 5%. And that was the last, and textiles, that was the last of them. They were sort of remnant. Most of them went during the second half of the 80s and early 90s. And there is quite a lot of literature in Australia on that, yeah.
Okay, I hope I can find that. That's very interesting. Thank you.
There's a question by Wolfgang.
Tatjana, thanks. These TRQs are hunting us as trade economists. So if I remember well, the WTO gives quite some leeways to their members, yeah, to administer the quotas. So I'm wondering, basically, is there information on this, and how does this interact with the idea, basically, that you have a kind of welfare optimal distribution of the quotas? That would be one question, and the second is another naturally important question: is where does the quota rent end? Yeah. So are you planning also to do something on this? Yeah. So in the CGE, it's important if basically these rents are treated like an revenue inflow to the government. Yeah. So as a tariff, or if you assume that somebody else, perhaps in another country, a trader is keeping the rents. That would be two questions as a follow-up. Thanks.
Thanks a lot. Yeah, that's a good question. I mean, the way I set up the equations, I just pretend that also the premium that is added to the price is taken into account with the same variable, just with the impacts. With the import tax. The model as of now probably just leads all of this money directly to the government. And you're completely right that this might not be the most reasonable scenario, and that I might have to think of another equation that redirects this kind of premium into a different direction if it is a premium, or if it is a rent of the quota. I don't quite know how to do that right now, but I also would not know if I would know it equation-wise, I would not know how to split that up, because depending on the quota system, some quotas are really administered by some form of auction. That's usually not the European ones. The European ones are either first come, first serve or license on demand. But there are Swiss quotas that are going with an auctioning system, and there it's probably reasonable to assume that the government gets most of it. In other quotas, it would be reasonable that maybe some of the quota rent is used to make the product even cheaper, so then it would go to the consumer. And in some cases, it might be, I don't know, that the quota rent ends up with some kind of trading firm in between. I don't think it will ever end up with the producer though, because from all I've read, the trading firms which take care of this whole quota administration process are usually not directly the producers of the exporting country. And I would not even know where to locate that then, if it goes kind of to the service sector of the trading firms. So yeah, that's something interesting to look into when you look at the big picture. Right now, I was just concerned about the distribution of the quota in the first place. Thank you.
Any other question or comment? We still have, I guess, a few minutes. No, okay. So I think that we can turn to our last presenter, Wolfgang, from University of Bonn. He will deal with, about a work with the title "Integrating Information from National Social Account Matrices into a Disaggregated GTAP Database." Wolfgang, the floor is yours.
You're muted, Wolfgang. Sorry.
Thanks. So this is common work with Roberto Rosen from Venezia and Seville and Emanuele Ferrari from the Joint Research Center. So this was work for the group at the GRC. So a little bit to why would you ever think basically of taking data from a national SEM and bring this into GTAP? I mean, that's what the GTAP Center is for, right? Then a little bit discuss how this process was organized, and then discussing a little bit about the pros and cons and what we observed before I summarize. So the whole idea which Tom Hurdle was come up was really to say, okay, let's bring our data together. So the established process is that data providers, they share an IO table for a country they work on with the GTAP Center, and then the whole community of the GTAP users benefits from their data, from this new data or better data we get. But there might be cases where, as somebody who is working on a specific project on a specific country and has produced a SEM, is perhaps not too happy with the process. The one is, I mean, we see data releases coming out every 3 to 4 years. So if you just start a project now, you might be happy perhaps to still get it in GTAP 11, but I doubt it. So then you have to wait 3 years until your improved data show up in the GTAP database. The other point is that the GTAP Center has well-developed build processes to integrate your IO data with all the other data they are working on. And in this process, perhaps there are changes to your data, so to say, which you don't like too much at the end. Yeah? And they might matter, for example, your client, because he would like to see specific data which he contributed to the SEM to then also show later up in the analysis. So there might be benefits from being able to integrate more information, perhaps, or more accurate information from a given single country SEM in a tailored version of the GTAP database. So how does the overall exercise looks out? So you harvest desired details, or all the details you would have from existing single country SEMs. And the benefit from this is that you might be able to move from a single country CGE over to an GTAP derived variant. In our case, that was CGE box, but that holds also for the GEMPACK family of GTAP models. So by basically bringing your SEM into the global database, you then have also a global model at your hand, and you might get all the fancy extensions Erwin has shown us: GTAP Power, GTAP HT, GTAP AEZ, yeah, perhaps multiple households, long-term modules, and so on, things you might not have yet in your single country CGE. Yeah. But the problem from this is, I mean, you need to override certain parts of the GTAP database in order to use the GTAP model with your data. So if you do this, you are losing the consistency which is underlying the global GTAP dataset. So you need to rebalance the GTAP database. Yeah? So I will guide you a little bit through the process, how we have organized this in this project for 3 countries. So the first thing in this is you need to look at what your SEM offers and what the GTAP Center offers, and then find a good compromise with regard to the product sector and factor detail you want. Yeah. So if you're lucky, that's mostly an aggregation exercise. So your SEM being less detailed than the GTAP data. So then you simply say, okay, that is the best possible aggregation which I can find, which matches my products and sectors factors against what is in the SEM. Yeah? It becomes a little bit more complex if in your SEM you have some products which really matter for the country at hand. Let's say you are looking at a copper exporter or a coffee exporter or tea exporter, where really this product is important for your clients. So you don't like basically to vanish this into something like fruit and vegetables. So in that case, you need also a split exercise, which we have done partly for what we did. Yeah. So with this aggregation, disaggregation first step, you are ending up with a database which has the desired product sector factor detail, but has not yet your data in. Okay, so the next step is now get the SEM and move this over to GTAP. With regard to the split, we were lucky for agri-food sectors. There is something out which is called the Fabio MRIO, which was released by Martin Bruckner and friends. That's open source, that's based on Farostat, and it has a lot of agri-food data. Yeah. Then you need on top a splitting machine such as SplitCom from GTAP, or in our case, we use something which is inbuilt in CGE box, yeah, which matches the Fabio definitions to the GTAP definitions, and then basically derives split factors from the database. So now you have this database, and now you have the SEM. So what do you do? Okay, so either GEMPACK or GAMS, you have those cross sets which can say, okay, this product here is linked to this product there. That's nice if that's one-to-one, because then you simply basically copy data from the SEM over to some GTAP data structure. I don't know. Factor returns at basic prices or something like this. Yeah, there's a cell in the SEM, and bips, there is something which in the GTAP database which matches to this. Then you can have the nice case where you have multiple products or sectors in your SEM and only one in your target GTAP database. So that's a straightforward aggregation. That's also nice. But then what we found is you get overlaps. That's very bad. So that means you have multiple industries in your country SEM which match to multiple industries in the GTAP database. So you have overlaps. Yeah? you could say, okay, let's aggregate this all, but then you are losing a lot of detail. So in that case, basically, you have now twice applications of some proportionality assumptions. And the outcome of this is typically that what you get out of your exercise by basically assigning SEM cells to the GTAP data structures is not longer internally consistent. Because those distribution factors, they should differ depending on the matrix and so on. So that can be quite demanding. So you need basically a balancing routine which works on the GTAP data structure, which is different than your usual SEM balancing problem, because the structures are not defined as a SEM. So that was quite some work. It's not easy to read those scripts. So that is one of the warnings already to send here. So that is not something you do simply in a few minutes. So the outcome of this is then a balanced data for a single country in the structure of the GTAP database, which the desired product and factor detail, but this will not perfectly fit to the rest of the world data in the GTAP database. So that brings us then to the third and final step. So you have now the data from the SEM, which sits here. And this you now basically bring in a correction step. We were lucky because the data driver of Cge box comprises a filter to take away small values in the original GTAP data. So we have already code which rebalances the global data set. So it was relatively easy to then say, okay, we add here a possibility for the user to bring in its own corrections in the data. They can relate to just a few numbers, or in that case, basically, they can simply replace more or less every data, which were in GTAP for a specific country. So you run this process through, and then you also have perhaps an additional split if you wanted this to add this on the data. So where are now the interactions between a single block of single country data and the rest of the world in GTAP? That's basically the trade flows and the foreign savings. As long as you are touching a relatively small single developing country, such as in our project, so we had 3 African countries, the required changes to the rest of the world trade flows are very, very small. I would say they are negligible. So the small inconsistencies from this you easily get out by using the corrector we have already in. I could imagine if you're updating the China or the US, and you use a completely different IO table that the one who's currently underlying the GTAP database, you could also see some larger differences in the rest of the world, and that then becomes a problem, because then it's probably hard for you to judge if this is really a quality improvement overall or not. So what did we observe during the exercise? So there is generally a very good agreement on the macro totals, which simply underlines that those statistical data are all probably coming from one common source, which is used by which are the statistical offices of those countries. That's normally not something people touch when they construct the SEM. They take this as controls. So that's not basically where you would expect that your SEM really changes a lot compared to GTAP. On top, most single country SEMs, they are not written in US dollars, but in national currencies. So you have some leeway to adjust the exchange rates to improve even the fit for the GDP or other macro totals more. With regard to exports and imports, we've seen some larger deviations, which doesn't come as a surprise if you understand how these data are constructed. So these are WTO notifications, and they are done for each country for their own exports and imports. So there is no reason to assume that what the US exports as exports to Ghana of a certain country is exactly equal to what Ghana reports as imports. Yeah? This is by calendar year, so some goods might be simply having left the port and not arrived at the other side. Yeah? There might be shipments which are partly lost, or you get a redeclaration according to tariff lines. Where also traders play perhaps BIF, or the custom point at your import station thinks that is something different than you originally thought the tariff line would be, and so on. Yeah? So the GTAP center has to reconcile this, because there is only one trade flow in GTAP, whereas in a single country SAM, you would normally take whatever your statistical office reports for the country and don't care if that fits to what other agencies report about your imports and exports. So that doesn't come as such a big surprise. Where we were surprised really was that there was, for many countries, a very bad match between the final and intermediate demand for certain product groups in GTAP and in the country SAM. That comes as a surprise, especially we have seen a lot less intermediate demand in the country SAM that we have seen in GTAP, despite the fact that our SAMs were newer than the ones in GTAP. And normally you would assume, okay, if countries are growing, you see economic growth, yeah, you get more well-developed value change. So normally, basically, the share of intermediate demand exchanges between the industries should grow and not shrink. Yeah. So one possible reason is here that the SAMs, they had dedicated home production activities. And then the question is, how do you interpret intermediate demand in something like this? Right? So think about, you have a cattle producer. A cattle producer produces part of its stocks for its own replacement. Yeah? That stuff is normally not taxed. It's normally not even reported in national statistics if you're in a developing country. Yeah? So it's now a question of how you construct your SAM. If you want to include this into the output value, but that is cattle production to cattle production, so you inflate your output by generating an intermediate input which goes from this process into the very same process. Yeah? So you can also leave that out. That does change the value added. That doesn't change final demand. It simply makes a matching SAM column and row smaller. Yeah. So it might perhaps those differences in the philosophy, how you book such transactions, which explain why perhaps in one SAM and another, you see for certain products quite some differences in intermediate demand. Yeah. It starts to matter if you have then also imports of these products, and then your shares clearly for domestic versus imported origin, they react to these differences in those booking philosophies, and that can impact then in the end basically also your simulation results. So that is something you should perhaps carefully look at, and also talk probably to the people who construct the SAM. There are some other open points. Yeah. So we were lucky that the SAMs we had, they were matching the benchmark here of GTAP. But what if you have really more recent data? So you have GTAP data from 2014 and now a SAM from 2019. Yeah. You shouldn't fudge the 2090 data and their macro totals against the 2014. That doesn't make sense. So somehow you would need then a way to update the GTAP data set to 2090. So you need something like nowcasting. Then it becomes complex. You would need some baseline generation model, yeah, which brings your data world to 2090 in order to integrate your SAM. That can be done, but it's clearly a further complication in the process. Yeah. Another problem is, what if you have not just one single country, where those consistency problems with the rest of the world are probably not a large problem, but you update a few of them, which on top have close trade relations. Then you are ending up with the problem that you have to reconcile the trade flows. So this is also something one should keep in mind if one tries this road. Yeah. So here are a few conclusions from this. We've seen it can be done. Yeah. So we get basically the desired detail and the data we wanted over into GTAP, and we could afterwards run GTAP models with single country data, which were coming straight from the SEM and were overriding what we got originally from the center. But it requires in-depth knowledge on the structure on the GTAP database, also on how those SEMs were constructed, and development of this mapping scripts and data handling scripts was quite demanding. It's not something which is an easy work. The other thing we found is that country SEMs, they can be quite different in structure from the GTAP database. You might have specific features in multiple investment activities, domestic margins, yeah, home production activities, and so on, things which you perhaps cherish in your single country CGE, but which are not easy to carry over in the framework of the multi-regional GTAP data. Yeah. And the last point is, I mean, it benefits your project, but not the rest. Yeah? So perhaps we should, as a community, think if we can perhaps make this process easier to also generate additional benefits for people to contribute IO tables. Yeah? Into a kind of more continuous data updating process, which is personalized with clear releases in between. Yep. Thanks for listening to this talk. I'm expecting perhaps some critical questions on why we are doing this or comments. Thanks.
Thank you, Wolfgang. There is a question by Fusini. Saying great work, technology, so input output is important. One of the issue we have and not captured in the sum in Africa is informal trade flows, which can represent 70% of trade between neighboring countries. The degree of openness of countries largely biased in official data.
Yep. I mean, I cannot answer you if the people who constructed the SEM tried to get estimates of this informal trade in. It's sure that you can, yeah, if you have estimates. And that could be one reason why you want to deviate from data from the ITC, for example, which are underlying the GTAP data in trying to override trade flows. Oh, yeah.
Erwin, please.
Thank you, Wolfgang, for this interesting presentation. Very informative. I'm just thinking about one particular part of the GTAP database, for example, the energy volume or the carbon emissions. So when you, let's say, impose the new SAM data from a particular for a particular country, were you able to look at how close or far off the energy value flows are pre and post inclusion of the new data, and how closely they are aligned to the previous energy volumes, for example, in GSD vol?
No, we didn't do this, but this is naturally a further point of caution. Yeah. So one way to go there, and I think that's the route we have taken here, is to calculate emission factors from the original data and then multiply them on the corrected data set. But you're completely right. I mean, if for example you have emissions linked to output, and then you have this different philosophy where certain parts of intermediate demand are netted out in the SEM, yeah, then your emission factor should go up. I'm currently thinking about a way basically of saying, okay, you take the given, I don't know, total energy demand or the total CO2 or non-CO2 emissions, air pollutions as given, and then you correct all the factors afterwards such that you end up with the original budget. Yeah. But that's a good comment. I mean, I would like to share this. I mean, there are so many interesting auxiliary data now out from the GTAP Center on land use, on CO2, non-CO2 energy use in million tons of oil equivalent, the air pollution data. Yeah. So if you start correcting your individual data, you can easily destroy basically those budgets and generate quite curious emission factors.
Sorry. There is a question by Omid Zamani in the chat saying, thank you for your presentation. Oh, I lost. If my question is not relevant, please ignore it. I just wonder if we can use shadow price of equation for those unmeasured variables or error as a proxy of unobserved variables.
Could you explain what you're referring to there? I mean, where are the errors you're talking about? The differences between the GTAP database and the country data?
Okay, please. Omid, can you explain by words, please? Here. Okay. No, we can't hear you. Okay. Maybe in the meantime, we can go to Hassan, who raised his hand, and then come back to Omid's question, maybe.
Thank you very much, Wolfgang, for the presentation. And I mean, I was involved at the beginning of the project, and I see I missed all the fun after leaving. So my question is, I mean, you said that, I mean, this wouldn't really help rest of the community, but it can, right? I mean, if you can submit this to the GTAP Center, then you would be giving them a very good starting point instead of, I mean, trying to reconcile everything. Maybe they will just check and see how it fits to the rest of the model with, I mean, in the new version. So did you actually, I mean, yes, this is a question also for the center, but did you talk with the center about possibility of, I mean, people using this facility or this feature, the submitting data, etc.? I mean, do you think, because then, I mean, that would be a huge contribution to the center and the community.
Yeah, very good point. I mean, if you look back at the starting point of this exercise, then it's looking basically at the match of the sector product and factor detail in the SEM versus GTAP. And I guess that is a challenge for data contributors, because you get the GTAP Center must basically have some kind of clearly defined rules. What is the kind of minimum detail you have to provide? Yeah, but that must not necessarily be the case for the kind of exercise I'm describing here, because you first aggregate the given GTAP database and perhaps split them up to come as close as possible to the detail you would like to have in your study. And that can actually be mighty different from what the GTAP Center would like to see, yeah, when it asks for an contributed IO table. So that is something where perhaps Dominique and others can comment on, because I've never contributed an IO table, so I'm not aware exactly how that process works, how much flexibility there is basically for contributors with regard to the detail they have to send in.
There is a comment by Hussein There are only a few countries having systematic evaluation of ICBT flows in Africa: Uganda, Rwanda, Kenya, and CILSS for a series of countries in West Africa. UNICA and the Afreximbank are working together to generalize it to the continent. In most of the case, ICBT is not taken into account in SEMS in Africa. This is an initiative we are working on at IFPRI because there are a significant gap there.
Yeah, I must say I'm even not aware of these acronyms, so I cannot say much on this. So I haven't constructed the SEMS. Yeah, so I don't know if Emanuele or somebody from the JRC is there and can perhaps tell exactly at which data they were using when they have integrated this into a SEM. Yeah. Oh, okay. Yeah, I was guessing something like this. Yeah. I think that is again, yeah. That's a question back to the center, basically, if there are ideas to bring this into the GTAP database.
Okay, we have also Dominique. Want to say something?
Yeah, I was going to tell Wolfgang that I didn't hold it against him that he's never contributed an IO table, but he has made other contributions. No, the center, I mean, we get new IO tables on a very regular basis. I mean, I'll mention it tomorrow, but we'll be adding 18 new countries to the version 11 release to be done probably later this year, plus many updates. So I think, so one issue is how regularly we issue new releases. To be perfectly frank, I mean, we do release new versions of the GTAP database to board members on a regular basis, so that, you know, Hassan shouldn't have too many complaints that we do release new versions to the World Bank and the other board members regularly. We're thinking about doing more regular releases as well to the public, as maybe even increasing the frequency of the releases. The concern there is kind of the reliability of the data. So it's some issue we'll have to deal with. It doesn't wouldn't solve all of Wolfgang's problems, though, because countries, you know, in a kind of a standardized template like database like GTAP, you're obviously are going to make you're ruling out certain institutional details, let's say, that are important for some of the countries. There again, we're hoping to improve the database. I'm not thinking so much about internal transfers, but I think we can improve the balance of payments significantly.
Yep.
And we already do that in part for remittances and profit flows, but we're going to add ODA and other official transfers as well. And that will deal with a lot of the issues, particularly when you're working with the smaller countries where some of these external flows are a large share of GDP. I did also want to mention the thing that Erwin mentioned, is that we do bring in additional information into the build procedure, notably the energy and emissions, and that would tend to generate pretty significant structural shifts internally, you know, if you're using an older database. Yeah, so if you're using, let's say, a 2005 database with 2014, and you get big changes in the energy balances and prices, you're going to see pretty dramatic deviations from the original database, at least for certain rows and columns. I'll leave it at that.
Mark, please.
I was just going to say that my own experience in the past of contributing country input-output tables I haven't had to wait that long to get the full data set back from GTAP. I've always warned them in advance, of course. Yes, it's not like I had to wait a year or anything. I don't know if the turnaround is still so quick.
I mean, these are good news, but I think that's also the special access relation, right, Mark?
Well, I don't know exactly. So, because, well, a contributor has special access.
Yep.
Okay, we have a question by Tatjana.
Okay, I just raised my hand in the name of Umid, who can't enter the chat right now. And I'm trying to pose the question that he meant as far as I understood it. So he kind of says, if we have lacking trade data because so much within the African community is maybe smuggled or in some way gotten across the border without appearing in the databases, then we might be able to see the shadow value that is apparently getting lost there if there is no trade. We could kind of see, well, if there were welfare maximizing, then apparently they would probably import something from the neighboring country and then get an estimation based on that. I personally think that that's very hard without a share parameter in the Armington CES, but I think that's the kind of question that was behind there.
Yep. I'm not an expert on this, so I'm guessing, but my fear would be basically that, I mean, it's not only the unreported trade, right? So what is imported there is also not, it's also not shown as intermediate inputs by some firm in a production process. Yeah. So I think these data are not only missing on the trade side. Yeah. So you're probably also missing them on the final demand side, in intermediate demand, on the output values. So basically there's a whole part of the economy which is unreported in statistics. So I wouldn't know basically how you could easily basically reconstruct the missing data from what you get from the statistical offices, right? If that would be the case, I'm pretty sure the GTAP Center would have done this long ago. Yeah.
Okay, I think that ends this session on software and model extension and development. I thank you, the presenters, Florian, Erwin, Tatjana, and Wolfgang for their very valuable presentation. And also I would like to thank the audience for the fruitful debate. We appreciate everyone joining us and hope you enjoy the remainder of conference. Thank you, everybody.